My name is Frank Ferro, and I'm going to spend a little bit of time with you talking about the latest in HBM2 and 2E memory technology. There's a lot of decisions that need to be made when you're developing high-speed products for AI, and HBM has become the memory of choice. So we're going to go through in a little bit of detail and talk about what some of those selection criteria are for HBM. So exponential data growth has really driven everything we've done today in the semiconductor industry. The increased need for data is stressing all of our systems. It's stressing the current computer architectures that we have, and it's really driving innovation to try to do things differently. One of the things that has really become mainstream for computing AI is neural networks. And neural networks have been with us for some time now. However, the compute power has not been there to keep up and to really do a good job with neural networks until recently. And so now that the computing is caught up, one of the things we're seeing is that we've got plenty of compute power, but the memory bandwidth is now becoming the bottleneck in the system. So you've got many processors, and you just can't keep these processors fed. The way it's been done today is using CPU and GPU technology. But as good as these CPUs and GPUs are, to get more efficiency out of your neural networks, custom processors are being developed. And with those custom processors, you need to have a very wide memory bandwidth. And HBM, as I just said, is really becoming that ideal memory. And let's look at now some of the specs around HBM. So two of the choices you have for AI ML, as I mentioned, is HBM, but you also have GDDR6. So when we talk about HBM, both of these technologies were developed for the graphics market. HBM2 and now HBM2E was developed in order to give you the kind of the maximum bandwidth with the current DDR technology. So if you look at the picture on the left-hand side of the screen, you'll see these kind of stacks of memory. So what it's doing is with HBM is you're taking existing DRAM technology and now you're configuring them in a 3D stack. So you with the same technology, using both 3D and 2.5D manufacturing technologies, you're getting much higher bandwidth. So really, nothing's necessarily changed from the specific DRAM, but it's the way you're building it. Another popular memory is GDDR6, again, developed for the graphics market, but because of its such high performance, up to 16 and now 18 gigabits per second, GDDR6 also looks like a very attractive solution for some AI applications. And at the bottom of the screen under each, you can see some of those target applications. So HBM has been a really good solution for AI training applications, because that AI training is very data intensive and requires the most, when you're training these AI algorithms, it could take days and even weeks to get the training right. And so you need lots of bandwidth and processing power combined. Once these models have been trained, then you have another process called AI inference. And AI inference takes much less compute power. It needs more cost efficiency because those are going to be deployed at various endpoints where these AIs are going to be implemented. And that's where GDDR6 comes into the picture. And we're going to talk more about GDDR6 a little bit later today. Before I get into the product, Rambus just recently announced our latest achievement in HBM. We achieved 4 gigabits of performance with HBM. And this is significant because right now the HBM product standard goes to 3.2 gigabits per second. And there have been some DRAM manufacturers, as you can see in our press release, have reached 3.6 gig. And so we've worked together with both DRAM manufacturers and our ASIC partners and the manufacturing partners to develop this high-speed test chip. And so you can see we've got, on the right hand, very clean eyes. This is the result of doing quite a bit of simulation work to get that interposer design right. Now with HBM, you're passing signals, you're passing many thousands of signals through a silicon interposer. And so getting that design right in terms of the crosstalk and insertion loss is very critical. So Rambus is known for its signal integrity as a signal integrity company. And so our ability to continue to lead the industry with the highest speed memory interfaces is just shown here as we achieve 4 gig. And as I just mentioned, companies that are developing AI hardware just need more bandwidth. So the ability to continue to push forward and get the maximum bandwidth out of HBM is very critical to these companies. So this next slide is a little busy, but I would like to talk you through it. And as we talked about selection criteria for different memories, I've introduced a few different memories on this chart, so you can really get kind of a picture of all the memories that are going to be used for AI. So starting from the left-hand side, we see LPDDR. Now, LPDDR was originally developed for the mobile market, LP standing for low power. And again, the industry is so pressed for bandwidth that LPDDR4, for example, was running at 4.2 gigabits per second. Well, at the time, that was one of the fastest memories on the market. So the application started moving beyond mobile. Similarly, as I just mentioned, GDDR6 and HBM2E have also kind of moved beyond graphics. So any memory system that's going to give you the maximum bandwidth is finding applications, especially in different types of AI. So LPDDR and LPDDR5, as you look at AI at the endpoints, and endpoints in the network really could be anything from something like your could be an automotive application, but it could be something as your home device like an Alexa or something like that, where you don't need a lot of processing power, and you need to be very low cost and very low power. But as we move through the network to the edge of the network, or even up into the cloud, then you're going to start running out of bandwidth with LPDDR, and you're going to need things like GDDR6 and HBM. Now, DDR memory has been there forever. DDR is the traditional memory we have in our servers and PCs, and they're still there today. DDR4, however, runs at 3.2 gigabits per second, which was, again, it's a very good memory system, very popular, but at 3.2 gig, it's just not keeping up with some of the demands of these new applications. So if we go across the top, you can see that HBM by far gives you the highest bandwidth at 3.6 terabits per second. So quite a bit of bandwidth out of each memory stack. And then GDDR6 at 16 gig gives you the next highest bandwidth. And then as you move into the cost area, obviously DDR is the lowest cost. So you need to look at the trade-off of what's going to give me the most performance, the best power, and the lowest cost. So in the case of HBM, you check most of those boxes, right? You're running at over 3 terabits per second. You've got the smallest area. You've got very good power efficiency because you're running at still relatively slow speed at 3.6 gigabits per second. You're going very wide and slow. But you do have more complexity when you have these 3D structures and 2.5D structures that you have to deal with. So the manufacturing cost is going to be higher. If you don't need all that bandwidth, the GDDR, and you want to use more traditional manufacturing methods, just to die down on PCB, then GDDR6 really gives you your highest performance. And then if you're really cost-driven or power-driven, then you can move into some of the LP DDR technologies. So this next slide gives us a look at what the Rambus HBM2 solution looks like. So in light blue in the center, you can see this is our memory PHY and controller. So this is a complete memory subsystem that's for HBM. the phi is provided as a hardened, completely time enclosed macro, and we validate that with our memory controller. So the combination of the phi memory controller really simplifies the engineering effort as you're developing your memory subsystem. So Rambus takes care of a lot of the heavy lifting regarding the memory. And our memory controller, which we'll talk about in just a little bit, has popular interfaces to the SoC or ASICs in the system. So some of the advantages of working with Rambus is we have a lot of production experience. As I'll show you in a moment, we have a number of HBM devices that have been in production for a long time. And again, when you're purchasing IP, having production tested IP is very critical. You want to know that it's going to work right and work the first time. The other unique thing about Rambus is we don't just provide IP, we provide a complete system design support. So we provide the reference design for the interposer and the package. And this again is a huge boost to companies developing this type of AI hardware, because we kind of take you, more than 3/4 of the way there when we give you the design. You get a reference design for the interposer, we give you design recommendations on the package, and you get a complete memory subsystem. So again, big advantage. And then finally, we provide a tool called LabStation, which is a very advanced tool that's been developed over the last 25 years at Rambus by our signal integrity experts, that allows both the IP to be fully characterized, and also it works with your systems, the customer systems, to bring up to help bring up your system. So for example, if you've got an ASIC that's powering up for the first time, once you give the phi and controller a clock, then LabStation will allow you to look at the interface just between the memory and between the DRAM and the physical layer in our phi, and get that up running debugged even while your ASIC is being debugged. So very powerful tool. Of course, from the feature side, we support all the standard features of the JEDEC spec for HBM, and you can see down on the bottom left-hand side, again, the speeds all the way up to 4 gigabits per second. We support all the different DRAMs. We support things like lane repair. There's an IEEE 1500 test support that's part of the standards. Again, complete phi ready to go. I also mentioned the interposer reference design. And as you can see here on the right-hand side, I've talked a lot about the interface between the processor and the DRAM stack. So you can see we have a little simplified block diagram where a processor with the HBM interface. And then you can see these kind of orange color signals going through the silicon interposer, and then these go over to the DRAM stack. And how do you design those signals going through the interposer? There are quite a bit of challenges that you have to be aware of when designing an interposer. For example, how long can these trace signals be? What is the spacing of these signals? What is the thickness of the metal? How many metal layers are there? Where do you place the ground layers? All these are different for every type of implementation. They're different for every type of process node. And so Rambus has reference designs for all the major manufacturers and for the different types of systems that you're going to be designing. So we've done this quite a bit. And we'll work with you on understanding your channel. We'll do the channel simulations, and we'll provide recommendations and feedback on how that interposer design's going to look. Okay, so finally, I'd like to talk a little bit about some of the products that are out there in the market. So we have HBM. Rambus is the leading supplier of HBM IP, and we've been doing this since 2017. Our first design that was announced was a 14 nanometer design based on HBM2 technology back in around 2017. And that's been in production for quite some time now. It's a 2 gigabit design, and it's being used by customers in AI. It's also being used by customers in the networking space. So very successful design. We've taken that design and moved it to HBM2E in a 12 LP process. And that's just recently been released, and that's in kind of pre-production stage. And then we're currently working on the next generation of that as a 12 LP plus design, and that'll be ready next year. We also have a 11 LP design on a different foundry that's also available now. And then you just saw the press release earlier. I showed you for the 7 nanometer HBM design is working in 4 gig. So we support many process nodes with the physical layer. Of course, the memory controller is not bounded by, it's a soft IP, so it's not bounded by the physical design. So you can see a complete portfolio of products. And with that, I'd like to turn it over to my colleague, Joe Rodriguez, who has responsibility for the memory controller products. So thank you very much.
Thanks, Frank. This is Joe Rodriguez. I'm going to talk about the memory controller solution. Appreciate your time, everybody. We do have a complete and configurable HBM2 memory solution with our controller and associated add-on cores. And it's very well deployed with over 50 customer design wins, as well as several test chips. We're able to help you with all your design, your architecture, any questions about your system interposer design that Frank was referencing before. We can also help you with your testing. We have a really great relationship with Avery VIP, as well as our own UVM-based test benches. We also have memory test and memory test analyzers that can help you with your hardware bring up in the lab or in the field. So we have a very wide variety of cores, including AXI interfaces to connect up to your standard SoC, as well as our native interfaces. And of course, you can have a number of ports that are enabled, AXI and our native interface. So that's all built up and is able to handle any of your architecture design issues or design bring up problems. We have lots of experience and are able to handle any type of design architecture and traffic patterns that have been developed in the AXI or the HBM2 design world. So let me continue and talk a little bit about the controller details, as well as a little bit of the evolution of HBM2. So HBM2 has been around for several years now, and it's evolved just like everything else in the industry. It now supports 12 high stacks, and with the addition of HBM2E, can now handle 24 gigabits of density per channel, which is an amazing amount of memory space that you have available now. So obviously, it's not just the density, but you need to get to that axis as quickly as possible. Part of that is the pin rate at the PHY, and right now it's 4.40 gigabit per second per pin, which is awesome. And then to use the memory capacity and the incredible pin rates, you configure the controller, essentially the blocks that I showed you on the previous slide, to configure your exact memory patterns, whether it's random, any size of traffic you have. We can develop a system to handle that to tune to your that design traffic patterns. Or if you have a very restrictive, small 32-byte memory accesses at a time, we can configure a dual memory controller solution for that. So we can basically tune your system to your requirements to meet your power with a lower number of gates, or higher efficiency with adding another controller and having the access to finer grained memory blocks of memory. So we can build any kind of performance. We have over 50 design wins and have seen quite a few applications in both AI, as well as data centers, and even scientific computing. So there's a lot of different markets and a lot of different applications for HBM2E that we can help you with. We've also added some really awesome features for RAS, reliability, availability, and serviceability, including ECC, and now adding ECC scrubbing. So those are all features, advanced features that can help you leverage and deploy this IP that's already been used. It's very efficient, high quality, and has the minimum amount of gate count. So it basically is built for you to take advantage of the HBM2E system and really great, create some awesome products based on your market. And we definitely take full pride in our ability to deliver this fully integrated with our PHY, Rambus PHY. We have 2 test chips. I think Frank may have mentioned that already. That includes our HBM2E PHY as well as the controller and the add-on core. So it's not just a test chip, but it's a system test chip that we've created and deployed with our PHY team. So in addition to hardware-based validation, like I was mentioning, we also have an extensive factory-based verification environment using UVM, the two-top architecture to leverage our previously existing infrastructure, as well as adding all the really awesome UVM functional coverage, stimulus and monitors that are available in UVM. We also use the Samsung and SK Hynix memory models, as well as the Avery Design Systems memory models and monitors. So we actually deliver the package, whether it's all the add-on cores together with HBM2E and the PHY packaged together, validated. We'll also deliver this UVM test bench, not the entire suite that we have internally, but we'll deliver an example test bench that you can run in-house together with the Avery Design Systems memory model that you can come up to speed and learn HBM2E in your house, and also leverage that experience and basically take that the high-level DUT that's been integrated and drop that into your SoC and have full confidence that that's going to be it's not going to take time for you to debug the PHY and controller interaction. It's really to everyone's advantage to have a high quality reusable IP delivery with the PHY and controller together. So that's what we do in-house and deliver that to you. And again, we have a lot of experience with the design bring up, not only the software validation, but in the actual lab, whether it's the first time you bring up your memory together with the PHY using our memory test analyzer, or maybe it's in the field where you have like some of the early deployments we had with the PHY vendors. There were some drop-offs, so they were able to use the extensive algorithms in our advanced memory test add-on core to validate the hardware scenarios, as well as in the field, as well as in the pre-silicon verification with simulation. So it really is a mature, full-fledged controller solution that we have available, and you can take complete advantage of that today. So that's our verification. So really, when it comes down to it, people are choosing Rambus because we are #1 in market share. We have first-time silicon success. So it's not just the pre-silicon bring up validation. It's not just the test chips we've done. It's the fact that we work together with you closely throughout the process, from the initial deployment through the verification and bring up experience. So we really look at the problems you may see and trying to make you knowledgeable about those before they actually become problems. So it's not just the fact that we have a high quality IP, it's the fact that you can use that as well. And we take great pride on teaching people how to use that PHY and control it together. Very high performance. So we're the first one to achieve 4 gigabits per second per pin. So that's an incredible achievement from our PHY team. And of course, the memory controller is fully able to do that as soft IP delivered. to you. It's integrated. We've done the test chip together, so the 4.0 or 4 gigabits per second per pin that we've been talking about, that's been validated in hardware. The PHY is delivered as a hardened macro, so there's no need for you to try and figure out how to tile that IP together. You work with that together with our soft IP, and we can do the complete timing arcs all the way through, including, and you still have the soft IP for the controller that you may want to continue to refine and configure as you learn about your design and before you create silicon. So we have a really flexible solution that's also the best of both worlds with a hardened PHY. We also have the knowledge of the interposer design. This is also very critical for for design bring up. And with this experience that we've had, not only with the PHY but the controller, we are able to share that and share that knowledge and experience together with you and work together with you hand in hand throughout the process. So this is sort of the key fundamental takeaways for our presentation. We're a leader, very mature, high performance, integrated, so it's high quality, easy to use when you license the IP, and we have excellent support and bring up this. It's one of the fundamental things that people tell us all the time is that they really appreciate our technical expertise, both pre-sales and post-sales and bring up.